Welcome, everyone. I'm excited to have you here today. We're about to dive into an important topic: fire protection for petroleum and gas plants. On this first slide, you'll see the title of our presentation. We'll be exploring key strategies to ensure safety and prevent fires in these critical facilities. Over the next few minutes, we'll cover essential fire protection methods, best practices, and safety standards specific to petroleum and gas plants. So let's get started. Let's take a closer look at OISD Standard 116. This is a comprehensive document developed by the Oil Industry Safety Directorate under the Government of India, specifically focusing on fire protection facilities in petroleum refineries and oil or gas processing plants. The standard provides clear guidelines, both mandatory and recommended, for designing and implementing fire safety systems. This includes crucial components like fire-water systems, foam systems, clean agent systems, and even mobile firefighting equipment. A key aspect of this standard is its emphasis on the loss prevention and control philosophy. It details specific requirements for fire protection across various hazardous areas, such as storage tanks, LPG spheres, process units, and loading gantries. The document also covers practical topics like storage capacities for water and foam, as well as schedules for inspecting and testing all fire protection equipment. Additionally, it stresses the importance of establishing mutual aid agreements among neighboring industries, which can be vital during emergencies. To summarize, the key points from OISD SDD 116 guide us on how to ensure robust fire protection facilities tailored to the unique hazards of our industry, reinforcing safety and preparedness across our operations. Let's take a closer look at the general information and scope of this standard. The key document here is the OISD Standard 116. This standard sets out the minimum design criteria and details that are essential for fire protection facilities, specifically in petroleum refineries and oil and gas processing plants. These installations handle large quantities of flammable materials, which obviously increases the risk of fire incidents. That's why it's critical to have inbuilt fire protection measures designed to contain any incidents and prevent them from escalating into major catastrophes. An important point to remember is that the firefighting services in these facilities are designed with a specific assumption: that external services, like the city fire brigade or neighboring industries, might not be available when needed. So, the facilities must be capable of handling emergencies on their own. Finally, the core of our fire protection philosophy here is focused on loss prevention and control. It's all about preventing fires from happening and controlling any that do occur, to minimize damage and ensure safety. This approach is fundamental to safeguarding both lives and assets in these high-risk environments. Let's take a closer look at the design criteria and fire protection systems outlined here. First, the basic requirement is that our fire protection facilities must be capable of fighting two major fires simultaneously anywhere within the installation. This ensures we have adequate coverage and response capability in case of multiple incidents. Next, it's essential that all tank farms and areas handling hydrocarbons are fully covered by a hydrant system. This is a fundamental safety measure to quickly suppress fires in critical zones. Moving on to fixed water spray systems, these are required for several specific scenarios. They are mandatory for all Class A petroleum storage tanks, whether they have fixed or floating roofs. For floating roof tanks storing Class B petroleum with diameters larger than 30 meters, fixed water spray systems are also necessary. Similarly, tanks with fixed roofs storing Class B petroleum larger than 20 meters in diameter need these systems. In addition, LPG and hydrogen pressure storage vessels must be equipped with fixed water spray systems to manage potential fire hazards. Finally, in hazardous locations and around process equipment, especially where uninsulated vessels over 50 cubic meters contain Class A or B flammable liquids, fixed water spray systems are required. This also applies to pumps handling Class A petroleum products located under pipe racks. These measures are all about ensuring we have comprehensive fire protection coverage tailored to the specific risks involved, aligning with our overall safety objectives. On this slide, I'll explain the key safety systems we're implementing for our tanks that store Class A petroleum products. First, we're installing an automatic actuated rim seal protection system on all existing and new external floating roof tanks. This system is crucial because it provides an added layer of security by automatically activating to prevent fires along the rim seal area. It uses linear hollow metallic tube detectors filled with foam-based extinguishing media, or an equivalent system, to quickly respond to any fire hazards. This rim seal protection works in conjunction with the existing water spray and semi-fixed foam systems, ensuring a comprehensive safety approach for our Class A floating roof tanks. It's important to note that these measures are designed to enhance fire safety, especially in high-risk areas. Moving on, we also provide a semi-fixed foam system for other types of tanks. This includes floating roof tanks for Class A and B products, fixed roof tanks for Class A and B, and fixed roof tanks storing Class C petroleum products that are larger than 40 meters in diameter. Overall, these systems are critical components of our safety strategy, ensuring that we have multiple layers of protection tailored to different tank types and storage conditions. It's about safeguarding our assets, our people, and the environment by implementing proven, reliable fire prevention and control measures. Let's talk about the fire-water system requirements. First, it's crucial that the system is designed to handle the largest flow rate needed. This means it should be capable of fighting 2 fires at the same time, or even just 1 fire in the most demanding scenario, such as when a floating roof tank's roof sinks. The idea here is to ensure the system can respond effectively under the worst-case conditions, providing sufficient water flow to protect the facility. Next, the system must be designed to maintain a minimum residual pressure of 7 kilograms per square centimeter gauge at the most remote point in the network. This is important because it guarantees that, even at the farthest point, the system will deliver enough pressure to effectively fight a fire. And of course, the pressure needs to be kept above this minimum at all times, so the network stays pressurized and ready to respond instantly whenever needed. All of these requirements are about ensuring reliability and effectiveness of the fire-water system, which ties back to our overall goal of safety and risk mitigation in our facility. Now let's talk about fire-water storage. The key point here is that the reservoir should have a minimum effective capacity of enough water to sustain 4 hours of operation, based on the main pump's working capacity. However, if the makeup water supply rate is at least 50%, this capacity can be reduced to 3 hours. It's also critical to position the firewater storage at least 60 meters away from any hazardous areas to ensure safety and minimize risks. Moving on to firewater pumps, these are dedicated solely to firefighting. It's important to note that at least half of the total flow requirement should come from diesel-driven pumps, ensuring reliability during emergencies. Each main pump should have a capacity between 400 and 1,000 cubic meters per hour. This range ensures they are powerful enough for the job without being excessive. Lastly, jockey pumps play a vital role in maintaining system pressure. Typically, you'll have 1 working jockey pump and 1 standby. Their capacity should be at least 5% and up to 10% of the designed firewater rate, which helps keep the network pressurized and ready to respond immediately when needed. Let's talk about the distribution network. The goal here is to lay it in closed loops as much as possible. Why? Because this setup allows for a multi-directional flow, which significantly enhances the reliability and flexibility of the system. If one part of the network needs maintenance or faces an issue, water can still be supplied from other directions, ensuring continuous operation. Typically, the pipes should be laid above ground, and it's important to keep them at a minimum height of 300 millimeters above the finished ground level. This height helps protect the pipes from accidental damage and makes maintenance easier. Moving on to hydrants, the key point is coverage. We need to provide at least one hydrant post for every 30 meters of external wall measurement or perimeter within the hazardous areas. This ensures quick access to water in case of a fire emergency, which is crucial for safety and effective firefighting response. By implementing these strategies, optimized distribution networks, and adequate hydrant placement, we're reinforcing the overall safety and resilience of the facility. These are fundamental to creating a reliable firefighting infrastructure that supports the entire system. Let's take a closer look at the foam and mobile equipment requirements. First, regarding foam compound storage, it's essential to calculate the total amount of foam solution needed based on the largest possible single-tank fire, and this calculation should cover at least 65 minutes of firefighting. The minimum storage volume is set at 60,000 liters for most installations. However, if you have tankages larger than 60 meters in diameter, that requirement increases to 77,000 liters. Alternatively, the storage should be sufficient to handle 2 major fires simultaneously, whichever amount is greater. Most of the foam stored, at least 90%, must be of the aqueous film-forming foam, or AFFF type, which is known for its excellent fire suppression capabilities, especially for hydrocarbon fires. Now, moving to foam application rates, particularly in the case of a full-surface fire. Say, if a floating roof were to sink, it's important to consider the rate at which foam should be applied. In such scenarios, we use a rate of 8.1 liters per minute per square meter of the liquid surface area. These points are critical because they help ensure we have the right amount of foam ready and can deploy it effectively in an emergency, aligning with our overall goal of maintaining safety and preparedness in our operations. Let's talk about fire tenders and what's needed in terms of equipment. The required number of fire tenders is based on the scenario of fighting 2 major fires happening at the same time. This ensures we have enough resources to handle multiple emergencies effectively. Specifically, we need a minimum of 3 foam tenders. Each of these foam tenders should have a foam tank capacity of around 3,000 to 3,600 liters. This capacity is essential because foam tenders are crucial for suppressing fires, especially those involving flammable liquids. Additionally, we need at least 1 dry chemical powder, or DCP tender. This tender typically has 2 vessels, each capable of holding about 2,000 kilograms of DCP. This type of tender is particularly important when it comes to fighting LPG or gas fires, where quick and effective suppression is critical to safety. By ensuring we have these specific fire tenders, we're making sure that our firefighting team is well-equipped to handle complex and simultaneous fire situations, which aligns with our overall goal of maintaining a safe and prepared environment. Let's talk about detection and communication. Detection systems are a crucial part of safety in these facilities. Hydrocarbon gas detectors should be installed in key areas like light hydrocarbon pump stations, LPG spheres or pump houses, and also in bulk truck or wagon loading areas. These detectors help us identify any leaks or presence of hydrocarbons early on, preventing potential hazards. Additionally, for areas such as LPG spheres, filling sheds, and around pumps or compressors, we need to have smoke, flame, or heat detectors with alarms. These sensors are vital because they can quickly alert us to fires or overheating, giving us the chance to respond swiftly and minimize risks. Overall, these detection systems are essential for maintaining a safe environment and ensuring effective communication in case of an emergency. They form the first line of defense, helping us detect issues early and alert the right personnel to take action. When it comes to communication systems, having an effective setup is absolutely crucial in managing emergencies smoothly. First, a public address system plays a vital role, as it connects all control rooms and administration buildings, allowing us to relay important messages quickly and clearly across the entire facility. Next, fire sirens are strategically located to ensure the sound covers the whole area, alerting everyone immediately in case of a fire. Additionally, walkie-talkie or wireless systems are essential for all fire tenders and key personnel, enabling instant communication on the ground and in the field. Lastly, we need a reliable fire alarm system that includes manual call points, automatic detectors, and a central fire alarm panel. This integrated setup ensures prompt detection and response, minimizing damage and prioritizing safety. Overall, these communication components work together to create a coordinated, efficient response during emergencies, which is aligned with our goal of maintaining a safe environment for everyone. Now, let's talk about fire siren codes, which are essential for understanding emergency signals. When there's a major fire, you'll hear a wailing siren that lasts for 2 minutes. This sound is designed to grab your attention immediately and signal a serious situation. If there's a disaster, the siren sounds similar to the major fire alert but with a specific pattern. It will be sounded 3 times, each time at 1-minute intervals, and the entire sequence lasts about 8 minutes. This pattern helps differentiate it from other alarms and indicates a larger-scale emergency. Lastly, when the situation is under control and it's safe to resume normal activities, you'll hear the all-clear signal, which is a straight-run siren lasting for 2 minutes. Recognizing these codes is crucial because they quickly inform everyone about the severity of the situation and what actions to take. Understanding these siren patterns connects directly to our overall theme of being prepared and responsive in emergencies. Let's now look at the importance of inspection and testing for our fire protection systems. First, fire water pumps need to be tested at least twice a week by running them to ensure they are operational. Additionally, once a month, we should check their shutoff pressure and auto-start function to make sure they respond correctly in an emergency. Moving on to the fire water spray systems, these are critical for cooling storage tanks and preventing fire escalation. Fixed cooling spray systems on storage tanks should be tested at least once every 6 months. For deluge systems on LPG spheres or bullets, the testing frequency is even more important. They should be tested at least once every 3 months to guarantee quick response times. Regarding foam systems, whether fixed or semi-fixed, these need to be tested annually. This includes testing the foam maker or foam chamber itself to confirm everything works properly when needed. Hoses are another vital component. All fire hoses should undergo hydraulic testing at least twice a year. This ensures they can withstand the pressure required during an actual fire situation. Finally, detectors. These are our eyes and ears for early fire detection. We need to test the operability of all types of detectors every 3 months. Gas detectors, in particular, require calibration every 6 months to maintain their accuracy and reliability. Overall, these regular inspections and testing protocols are essential for maintaining our fire safety integrity and ensuring that all systems perform effectively when it truly counts. Let's talk about training and organization. First, it's essential that a fully equipped fire-fighting organization is in place. This means having personnel who are not only trained, but also possess the right professional qualifications to handle fire emergencies effectively. Next, setting up a dedicated fire training ground is crucial. This facility should have basic training amenities and simulation capabilities for different fire scenarios, such as trench fires, open-top tank fires, pan fires, and pipeline flange leak fires. Practicing these scenarios helps ensure our team is prepared for real emergencies. Additionally, refineries and process plants should establish written mutual aid agreements with nearby industries. These agreements clearly define responsibilities, procedures, and the minimum resources that can be exchanged during emergencies. The core purpose of mutual aid is to ensure that help arrives quickly, minimizing response time and saving lives and assets. Finally, every installation must develop a detailed fire emergency procedures manual. This manual outlines specific actions personnel should take during a major incident, providing clear guidance and ensuring everyone knows their role. Altogether, these elements form a comprehensive approach to fire safety, emphasizing preparedness, quick response, and effective coordination, key themes that support our overall safety culture. Please subscribe my channel. Thank you so much for your support throughout this presentation. It really means a lot to me. Subscribing helps me to keep creating valuable content and sharing more insights with you. If you found this presentation helpful, I encourage you to click that subscribe button. That way, you won't miss out on any future updates or new topics I cover. Your support motivates me to continue delivering quality material. So please subscribe my channel and let's grow this community together. Thanks again for your attention and support.